Over the Christmas holiday, a nice little game jam was set up using specifically the Odin programming language, which I participated in and submitted a game. This jam was hosted by Karl, who wrote the Odin book and also made a game with Odin, and he wanted to do a jam just for Odin, so that was something I've been working on, so I participated myself. It was a 48-hour jam as seen in the requirements that started from the 27th and ended on the 29th. There was no sort of specific requirements, you just had to make the game within 48 hours, and that majority of the code had to be coded. So any libraries and tools, that was okay. That could have been done before, but the actual gameplay had to be done within the 48 hours. There was an optional theme, which was the above ground and underground, so that was optional just to give people an idea. But besides that, you could just do what you want. It just had to be made within those 48 hours. So for my game, I did Root Runner, which was a game using L systems, and the goal was that the player had to generate the roots of the plant and modify the rules to reach the water to allow their plant to grow. The game itself wasn't really fun, but it was very fun to work on, and the idea was very unique. I think given more time, maybe if it was a week-long jam, then I could really work on the fun start of the game and flesh it out. 48 hours though, pretty impressed with what I got within 48 hours, however, so that's good. And you just, not really about winning, it's just about learning at the end of the day. Let's just play the game first. So you start and exit, and if you start, you would jump straight into it. And you can see that you're just given a few options on this randomly generated world, and if I press generate, boom, that's what happens. And see here, the rocks actually block your tree, or roots in this case, and you can change between different modes. So for example, seeking gives you different results, like longer ones, and then you had spreading, which was way more dense and spreads out, and then you did have dense, which was this type of rule set, and you could have certain amount of energy, and then you could apply a rock pierce to it, and you can see it punches straight through. In this case, that was enough to get through, and once you do, it generates a nice random tree, and you're given two options. You can either increase the length or max energy. So in this case, just increase the length, and you just go on to the next level. So that's spreading, and then you also have water attraction, which goes to the nearest water point, and if I and I add a bit of water piercing, you can see that it's kind of going in that direction, and go through, not enough, seeking, there we go. So that's what you can do with the game, and that's really just it. And the levels are endless. It's just this randomly generated level that is just made at the moment. So let's look at the code. So what was already made beforehand? Was there stuff made beforehand? I already had knowledge and a base code for generating the L systems. I did modify this heavily down in order for it to work for the game jam, and you can see that in stuff like, is it a tree or is it a root, were unique to this. We can get into that later. And also this tile map that I had, I've also had this pre-prepared, and this was just rendering that water, the background you saw, like the water and the mud and the stones. That was all it was just used for, so it didn't really affect any of the gameplay at all. It was just a visual thing. Game was just set to 1920 by 1080p. 48 hours, there's just not really enough time to really start tweaking and getting a resolution play for everyone. Some people obviously can get it done, but for this I just set that as a default resolution. 1080p is the most popular one. I'll just set it as that. Unfortunately, some people probably couldn't who had a smaller resolution, and people who had a bigger resolution might have had a hard time. But with that, I just stuck for that for now. I think in the future I would have used a render texture 2D, so it would have been this certain resolution, and then I would have just scaled it up to whatever, or scale it down. It would have been so much easier and would have had a lot more consistency to it. So that's just something a future note. I also used Ray GUI for the buttons here. I also, of course, used Raylib as well, just as all the rendering and all that, the actual game framework. But for the GUI, which is great, you just set up a button and it clicks and it works. However, scaling the text is a bit annoying, and changing the font, I just left as it was. So the font is kind of small, a bit too small, especially if you're trying to do 4K. It was not great. So I think next time I'll just create my own buttons. If I ever do another game jam, I can obviously have that sort of code prepared or the knowledge on how to make it beforehand, so that would save me a lot of time. For the generate level, it's actually the player just passes in the seed. So level 1 is just the seed of the level. So if you go to the level and then generate level, you can see it's actually just seed. So whenever the player completes a level, they just increment that by the next one. And so technically, theoretically, there's like a billion different ways of levels to get through. But that's it. Rather than randomly generate seed, I was like, you know what? I'm just gonna make them start with one and they just progress through. Why not? It works. It shows the concept, and it was fine. Other thing that we just scrolled past was the low level. I did have some custom levels here. I obviously left this code in here, so that it was that the player was just gonna load it. These were made of tiled, so here the levels are just CSV files, and it was like, oh, 0 is the mud, 1 is rock, and I think 2 is the water. Yeah, and I was gonna have some. Yeah, but obviously I think player-made levels would have been much more fun and interesting, but I was sort of running out of time. I was like, you know what, I'm just going to focus on doing something else, which was the L systems, to make them more interesting, and then the level part can be just left out. So you can see that the ones with the rocks, so this one, it would have been like, oh, you had 3 tiers of rocks to get through before you can get to the water, and this one was like a big dome, and the water was in the corners, and it just didn't really work, and so I was like, I'll just leave that out. But the code is actually still there, including the levels. Other cut content was some of the textures I had. This one is fine, I think. Oh, these are the flowers ones. Here's a more big one. So I wanted to have wood types. These might be lower resolution, so let me swap to GIMP. So this is what they were. What I wanted to do was to have like different wood textures for your tree to generate. As you can see here, and these were like wang tiles, different leaves that you could have as well that had a little noisy edge. You could see all of these like flowers as well for your tree. But I never got it added. It would have taken too much time to have like a whole tile map and then figure out the length within a tile within the grid, rather than choosing the line and then picking a color. I would have really liked that. I think that would have been really cool. To create those textures, I use my software Pixel Textures Forge, which was a little tool that you can use that lets you convert like an image to a pixel art and a texture with like a noisy border that I've been working on. I did actually do a video of this as well. You can see me demonstrating it. This was an older version. I've updated it since, and you can see that you can make your wang tiles, and that's what I did. So that I had a couple of Creative Commons textures that were available, and I converted them into pixel art of 32 by 32, and then created a wang tile. It's still obviously used for the water, rock, and dirt that was in the game, plus also the grass in the top. They were used with that as well. In terms of other cut content, one was called a branch, so that meant that the player could, alongside increasing length and energy, they could also add another branch to their L system roots, so they could have, technically more roots growing. However, this would lag your game very quickly, because the way L systems works, they work in a Fibonacci sequence, so they exponentially increase. So adding a new piece of branch would greatly increase the load times. So I removed it because it would only take a few levels before you probably crash your system, because it was taking so long to generate the root system. Another part that's not in the code but originally was in the early version, was a collision avoidance. So the idea was you could avoid the rocks and snake through it, which I think would have been really fun. But again, that would have been too difficult, would have time consuming, because it's kind of figure out what way should the route turn. Should it turn left or right? Because it could turn left and then go into more rocks, so it wouldn't really avoid a collision, so it could have completely avoided a collision. So you would have to detect which way to turn. And that would have to go against perhaps the water attraction, because the water attraction is trying to pull it in. So I left those out, and instead just what if we just pierce through the rock instead? So that's all the cut content. Let's look at the main content. That being that a lot of the way I stored all the stuff was just in struct. So there's the rule stats, so that's the starting string, the angle and its length. And then we have a bunch of enums, so if it's dense spreading and all that. And then we have the modification struct, the energy. And then there's the perma perk struct, so that was all your energy. And you can see branch was there, like I said, was cut. And there's just a few low rails, player win, and what perk they selected, and their current value of the perma perks. A lot of the code is actually just so simple, because we're just actually drawing a bunch of buttons and then just modifying the rules. So for the draw modification UI, it's just all the buttons, and then once that button is pressed, we just switch it. So rule switching, we just pass in the enum, so whatever value it is, and we just go through one by one, and if it's the max one, then we just reset back to the start. It's just a bunch of switch statements, and it just modifies those rule stats, axioms, and rules. That's it. And there's a set default when the player wins, for example. So player win UI, just display that. It's just checking, hey, have they selected a perk? If not, then display this, and then if they have, then just clear all the memory. So in this case, clearing level, the water source, the root, delete the roots, the plants, reset everything back to a empty structs arrays. Set all the rules so that increase the kernel, generate level, then recreate the tile map, which is a 4 bits. So the actual code for generating the routes are here. It looks simple. That's because it's mostly handled by the system, which we'll look at. It just gives you the string back, and you just pass it in, and it'll give you the meshes or where the positions are. So it just gives us the X and Y position, so we know where to render the raw lines. And these are just stored in a global string. Same for the plant. So if the roots had hit water, so it returns a true or false if it hits water. If it has hit water, then we can generate a tree, and that's it. As we go deep into the L system code, we see we're actually just defining the rules within it as they are, and then it just kind of selects it. So when we create the L system, we just give it how many times it needs to go through, what its starting string is. If it's a tree, we just check in the tree, because here obviously we were meant to do a branch. We don't need that. And we also do it to pick a rule. So the pick a rule is just depends on if the chosen rule is based on what the root mod's current selected rule selection is. If not, then it will return it as a chosen rule. And this all it does is check because it's a 2-dimensional string. We just check the first one is rule 0. Is it a 2-dimensional? I think it's yes, it is the double one. So that's because you can do this on it. So you can do two rows. So it's a 2 size of 2 ideally. Where was I? So we scroll here. Yeah, so when you pick a rule, the first rule is like the one you check, and then it gives you that random choice. But in this case, I have it hard coded in. This is for the tree, so that to make the tree random, it chooses a random rule. So if you can see here, you have it extended. There's multiple ones, and it just picks any of those 4 to choose, and it just adds a bit of variation. So each tree you make when you complete level is randomized, and there are technically, many hundreds of possibilities because of the modifications. If not the roots, it just always returns the next one. There's no randomization. I was tempted to add randomization, but then you could just keep pressing generate, and it would always do random possibilities. You could obviously give them the specific seed, so it always generates the same results, but they could get a seed that makes them incredibly unlucky and possibly just never complete the level, for example. So it just added too much randomness, and you don't want too much randomness because you lose a lot of control then. The meat and bones are in the draw L system, which you give it the strings that you generated previously all up here, and you give it the distance, the angle, the start position you want to start on. So usually it's 0, 0, but for us we start in the middle. So if you think about it, half the width and half the height as well. It's a vertical angle. It used to be, because I used to support 3D in my one I have on the GitHub, which was a horizontal angle. Obviously I don't need that, so I just removed them. And I had a custom one, which is it a root? And all that does is, if you're generating a tree, it should generate upwards, and if it's not, it just has some slight modifications. And we also return a ball, which is for the water alongside its positional information. So again, if we check, I just check if it's a root, just because I want a bit of randomization with the tree, so it changes the length. But if you're wondering how do you get the angle from it, because you can give it the angle, well, you need polar to Cartesian coordinates, and that'll give you the nice juicy XY position. So you give it the radian, which is the distance in this case, and the angle you want to go through. Use a bit of cosine and sine, and that gives you the X and Y position. That's how you get the perfect angles. So if it's a moving forward, we need to check if there is root collision. Is somewhat in the collision code, of course, which is just this. So it's the current position, and then we want to pass in where we want it to go. So we do take a good old step approach. We go through the number of steps. We then convert it to the tile grid size, so we divide it by the cell size. In this case, it's 32. And we're just checking, hey, firstly, we're going to make sure it's within the array limits. And if it's above 0, we don't want to get into negative arrays. It'll get an overflow exception. And we just tell it, hey, is it rock? Then we return true. If it is water, we just double return else. We just return the false. That's it. That's really simple. Collision, and it works fine. And I've lost my code. Here we go. And so if it hits water, we just set that variable, which is up here, as true, and then we just keep generating the whole system. If it's not, then we know it's collided, it's true, and then we just give it the new distance, which is add in our rock pierce, because the rock pierce is a point value. So we're technically, if we times our distance by 1, let's say our distance was 1 and we times it by 0.1, we'll get obviously 10% of the length, so that would only meet 0.1. So that was the rock pits, you can get through it, but you can only you have a reduced distance you go through. For the water, it takes a very naive approach, and just because of the limited time that you have, we have a scaled end Y. Do we have a scaled end Y? This looks like legacy code. Yes, it was legacy code, and it doesn't change anything. But we have this closest distance that we set to which is a very high number, and it's because we're calculating the Manhattan distance to find the closest water. So we just use the scale position, or in this case, divided by 32, which should be the cell size, and that will give us the water coordinates. We convert it back to the actual size so we can navigate to, and we use a tan 2, which gives us the angle. We just use it from whatever position, and it kind of works out a lot of issues with this, and it seems to work okay enough. And we have this move towards, which just kind of gradually increases the angle. So it's again, the attraction has a certain strength, so the more high percentage of it is, the more likely, or the more closer the value is going to be to the new angle. And it was okay. It could have been much better and more improvement. Also, with the water, we're literally just looping through all the water sources. So there's if there's a clump of water together, you don't want to check each distance between each one. You'd want to get the average distance and say that this is you then calculate the distance from it. So that again, you'd have to use a fill algorithm to detect if it's a clump, a whole group together. So there's just not enough time for that. There's only 50 water sources at most, or on average, and most systems are going to be able to handle calculating a loop of 50 and using the Manhattan distance, which is pretty fast. So yeah. Aside from that, they're just checking if it's a certain character, it'll change the angle. If this one, it will create a stack, so the stack is just saved in an array, and then you add to the stack, and then you pop the stack when it's this character met, and that's just how you get the branching of different positions. So you retain the original position, you create one there, and when the stack pops, you go back to the original one, and it goes and do that, and we just return it. That's really it. That's really just all the core code. There's really not much else, I don't think. No. There's only 40 hours, so obviously it wasn't going to be much. Obviously, we just rendered the plant and the tree. The green leaves, the way they shake, it just generates some random every frame. So that's why it kind of has this nice wavy effect. So I kept that in. I thought it was nice. Another thing is I only compiled it for Linux. I did provide the source code, and because that was okay with Karl, the host, who's you just had to provide the source code really. And if you could compile it on Windows, you could compile it. And I was confident I could compile it because I didn't use anything that was unique to Linux or anything that couldn't work on Windows. So it compiled completely fine and it ran fine as well. So I do have Windows as a dual boot, but I didn't have Odin installed on it. So I didn't want to have to go through the effort of switching to that operating system, install Odin, and then compile it, check if it works, and then put it on for now. I think I had enough time, but I didn't want to risk it. What would I have done differently if I had to redo it, if I had another chance? I think I would have focused on it being a simulation rather than a game. So the player would just generate a bunch of nice little trees that had different flowers, and they could maybe could propagate them, and then they get a new tree that generates random, and then they could just have a little garden and just focus on purely the L system rather than trying to make an actual game with levels in. I think that would have been more fun and visually more appealing, because I think this game's not very visually appealing. The resolution is not correct for it. So this 32 by 32 resolution of the bricks and dirt, you just can't really see them. That the resolution is too big for it. It doesn't really make sense. I should have zoomed in significantly more, but then you couldn't see the tree, and it's just it'd have been complicated. I do recommend checking out what people have made on this. There was 46 entries. And I think there was about 150 participants, and so just for me to get the game finished and submitted, it's already impressive. It's 1 out of 3 people submitted something, so it's already an achievement if you can submit a game, depending on what it is. So I'm glad I got that done and was able to. But there's some amazing results. Some people worked in teams, so the one that won was Deflect Dungeon, and you can see they did a fantastic job with this, and it actually is a core. Actually has a pretty good gameplay loop. Would I keep working on this game after the game jam and make it into a fully fledged thing? I don't think so. I think I had fun with this, but I like the way it was. Obviously, if I did want to make a game, I think I'd focus on like a Zen garden, grow a bunch of different trees, and maybe that would look better in 3D, but that means requiring learning OpenGL shaders and stuff, so that would be like a far future, and I'm currently working on other things at the moment I want to finish, so I don't want to start anything new, but this was fun to do within 48 hours. Karl is thinking of doing more game jams, maybe a week-long one, which I might participate in if I have the time, and that might be quite fun as well to do, within a week long, and that can be something that I just do in the morning before work or in the evening before after work. There's no like pressure to get it completed. I mean, some do have monetary rewards in jams, but you should really focus on just learning something and getting something out there. So I think that covers everything about the jam and my game, and all I can say is to like and please do subscribe to my channel if you haven't done so already, where I have more content coming up. And if you're still here sticking around, then yes, check it out. I have a new camera for any of you people that are regular viewers. Santa did come, and I've got a nice new setup. I look so much more professional, and you can actually see me much better, and it's not flashing or turning bright orange as well. So we're making upgrades finally. But anyway, thanks if you're still here. See you then in the next one.